Okay, business algebra, let's wrap up 3.4. Some more word problems, and we'll do a graph on the next page. A projectile is fired straight up from ground level. After t seconds, the projectile's height above the ground is s feet, given by the equation. S is negative 16t squared plus 176t. Find the number of seconds it takes to reach maximum height. Again, this is a fancy way of asking for the x value of the vertex. So normally it's x equals negative b over 2a. In this case, the equivalent is x equals s equals negative, or I mean t. It's negative b over 2a because we don't have x and y. In this case, it's t and s. It's still the same though. It's negative 176 over 2 times negative 16. The negatives cancel. 176 divided by 16 is 11. So this is 11 over 2, or 5.5 seconds. So 5.5 is useful for us, but when we plug back in, we would rather use the fraction, and we'll see why. So find the maximum height. That's really asking for the s value, or the y value, at 11 over 2. So s equals negative 16 times 11 over 2 squared plus 176 times 11 over 2. Squaring negative 11 over 2 is 121 over 4. We can reduce. Negative 16 divided by 4 is negative 4 times 121 plus 88 times 11. Now we multiply. This is negative 484 plus 968, which is positive 484 feet. So after 5.5 seconds, we reach a height of 484 feet, which is pretty high. If you try to throw anything in the air, you think that doesn't take very long. To take 5.5 seconds to reach maximum height, you have to be going with a lot of initial velocity for gravity not to bring it down quickly. If you throw a basketball in the air, it usually comes down in 3 or 4 seconds, much less reaching maximum height in probably half of that. So that's pretty impressive. Okay. Convert into vertex form by completing the square, then graph the function. Now, we can complete the square. There's also a second option. If you are smart with your negative b over 2a, you don't actually need to use completing the square. So if that's something you would prefer to do, we're going to go ahead and do it that way. We're going to complete the square this time, and we'll do that on the second problem. So to complete the square, you move the 7 over, and we'll move it back over in the end. And you leave plus blanks on both sides. To complete the square, you take 2, cut it in half, which is 1, and square it, so you need a 1 there and a 1 here. Negative 7 plus 1 on the left side is negative 6. This is now a perfect square. It's x plus 1 squared. Then you can, this should be a minus 6. I don't know where the equal sign came from, and you can add the 6 back over. So f of x equals x plus 1 squared plus 6. What does that tell you about the vertex? It's negative 1, 6, which we can graph. We know it's facing upward, but we can still make a table for values. We have negative 1, 6. Things that are near negative 1 are negative 2 and 0. Plugging in 0 is easy. When I plug in 0 to the original equation, for example, I know that all the x terms go away, so these will both be 7. Let's plug in one other thing. Negative 3 or 1 are the next in line. I'm going to plug it in here so we see what this looks like. F of 1 equals 1 plus 1 squared plus 6. It's 2 squared plus 6. It's 4 plus 6, which is 10. So negative 3 and 1 go to 10, so 1, 10. Negative 3, 10. The rest is going to be off the graph. It's not too bad. It's true that you could have found the vertex without converting it into completing the square, but it's not that hard to complete the square. But you don't have to if you don't want to. Convert f of x equals negative 2x squared plus 8x minus 5 into vertex form. Let's try by using the vertex instead of completing the square. Okay, so we know x is negative b over 2a. That would be negative 8 over 2 times negative 2. That's negative 8 over negative 4, which is 2. Okay, so we know the x value of 2. Now let's plug into f of 2 equals negative 2 times 2 squared plus 8 times 2 minus 5. That's negative 2 times 4 plus 8 times 2 minus 5. This is negative 8 plus 16 minus 5. This is 8 minus 5, which is, I think, 3. So we have the vertex to 3. Now recall the form for vertex form is f of x equals a times x minus h squared plus k. Remember that our vertex is hk. So it's x minus 2 squared plus 3. The only thing we're missing is a. But remember, in the original, f of x equals ax squared plus bx plus c. We know a from the original equation. There's a reason these are labeled the same thing. A is whatever is in front of x squared. So as an alternative to completing the square, you just bring down the a, which is in front of the x squared, negative 2, times x minus 2 squared plus 3. And you can actually square that out and verify they get back there, but this is a way around the completing the square process if completing the square is not something you would want to do. So I don't think it's a bad idea. Okay, one last word problem. Suppose the supply and demand curves for an item are the following. P equals 150 minus 6q squared for demand, and P equals 10q squared plus 2q for supply, where Q is the quantity demanded and supplied in hundreds. Find the equilibrium quantity and price. So again, for equilibrium, we set them equal to each other. 150 minus 6q squared equals 10q squared plus 2q. This is quadratic, so everything has to go to one side. Plus 6q squared minus 150. So we get 0 equals 16q squared plus 2q minus 150. This is quadratic. We can divide everything by 2. 8q squared plus q minus 75. Now, normally we would like to factor this. 8 times negative 75 is negative 300. So we're looking for factors of negative 300 that are, it looks like 1 apart. That's negative 600. What am I doing? And this would be 24 and 25. So negative 24 and positive 25. So this helps us break our middle term up. Minus 24q plus 25q minus 75. Factor by grouping. 8q times q minus 3 plus 25 times q minus 3. So when I factor, I get 8q plus 25 and q minus 3. This produces either q is negative 25/8, not likely, or q equals 3. You can't produce a negative amount, so it has to be this one, so 300 units. To find price, I'm going to plug that 3 in to either equation. So P equals 10 times 3 squared plus 2 times 3. That's 90 plus 6, or $96. So our equilibrium is $96 and 300 units produced. And that is the end of 3.4.